Okay, good afternoon. Good afternoon for all of you. Yes, last class I have given this problem. I don't know how many of you are solved this problem. A clock in a spaceship emits the signals at intervals of 1 second as observed by an astronaut in the spaceship. If the spaceship travels with a speed of 3 into 10 to the power 7, almost equal to the velocity of light, you see that. Okay, 3 into 10 to the power of 8, 3 into 10 to the power of 7 meter per second. What is the interval between the successive signals as seen by an observer at the control center? Control center will be there on the ground. Okay. Here, between the intervals is equal to the two events. The two events interval is equal to 1 second. But here it must be more than that. Correct. It must be more than that. Let us see that. Yes. So here, yes, I can ask any one of you. Asha left the meeting. Akash. Akash. Aishwarya Matthew. Aishwarya Matthew. Present. Unmute and talk to me. Sanjay. Nicholas. Nobody. Vinay. Oh. A clock in a spaceship emits the signals at intervals of 1 second. So here T0 is equal to 1 second. As observed by an astronaut who is present in the spaceship, if the spaceship travels with a speed of 3 into 10 to the power 7 meter per second, then what is the interval between the two successive signals, between the two events? What is the time interval which has been observed from the ground? So means T is equal to how much? Where of course C is equal to 3 into 10 to the power 8 meter per second. Formula T equals T0 divided by square root of 1 minus V square divided by C square. Okay, substitution, you do it, get the answer, how much you are going to get? T is equal to 1 square root of 1 minus V 3 into 10 to the power 7 divided by, this is 3 into 10 to the power 8 whole square, you can put, no problem. Yes, square root of 1 minus 3 get cancelled, it goes to numerator, you will get 10 to the power minus 1 here, 10 to the power of minus 2. Okay, 10 to the power of minus 2 means 0. 0.1, 10 to the power of minus 1 means 0.1, this is 0.01. So therefore T is equal to 1 divided by root of 0.99. How much you are getting? Okay, Rigo, right? 1.005. Third decimal, fourth decimal point, whatever you are getting, you write, but unit you have to write carefully. Okay, Stephen. Write the next problem. Problem number 7. Continuation from the last class concepts. A particle with proper lifetime, a particle with proper lifetime of 1 microsecond moves through the laboratory at 2.7 10 to the power 8 meter per second. Question number 1. What is its lifetime? What is its lifetime as measured by observers in the laboratory? Question number 1. Question number 2. What will be the distance traversed Question number 2. What will be the distance traversed? Means how much is the distance traveled? Okay, what is the distance traversed by it before disintegrating? Before disintegrating means before dying. Before disintegrating is the question. Okay, yes, read the question. To read the question properly, a particle with proper lifetime. You read it. You read it. I told you already how to solve the problems. First, you had to read 2 or 3 times. Understand the problem completely. What is the meaning of the problem? Then we are supposed to write the data. Once the data is ready, concerned formula I had to write. Then substitution calculation. Last answer with SI on it. Okay. Yes. Now data we are supposed to write. Krupa, answer it. What are the data that I supposed to write? Krupa, if you are not talking, whether it is right or wrong, you are supposed to open your mouth. If you don't talk, then I will going to remove from the class itself. Switching on the link and going somewhere else is no use now. Yes, yes, quickly. Akash, Nicholas, Krupa, you do one thing. Krupa, you unmute and talk to me. Not necessary to type. Right? First idea, a particle with proper lifetime of 1 mu s. 1 mu s is given. You tell me that. What do you mean by this 1 mu s? What do you mean by this? Krupa. Rosemary. Aishwarya Matthew. Sabha. I'm asking one by one. Let us see. Sabha. All of you are actively participating. I told you not necessary to type, unmute and talk to me. Just you unmute first. Sabha, unmute. Otherwise, I will not solve the problem. You solve it. I will give you the problem only. Yes, what is the answer? You tell me. If you don't want to talk, if you don't want to answer, okay, do it by yourself. Next problem you write. Next question. In experimenter, I will not write that also. I will dictate, you write it. Because if you are not following my words, why I have to take so much amount of risk to write everything? Okay, you solve it by yourself. You don't want to learn, then what I had to do? Almost I asked around about 8 students. Nobody has opened their mouth. Hey, second sem students are better than you people, yeah. All of them, they are participating actively. Whether it is right or wrong, you have to answer it now. Okay, next question. Right. An experimenter observes. An experimenter observes a radioactive atom. A radioactive atom moving with a velocity. Moving with a velocity of. An experimenter observes a radioactive atom moving with a velocity of 0.25 c. 0.25 c, where c is the velocity of light in air or vacuum medium. 0.25 times c, full stop. The atom then emits. The atom then emits a beta particle. The atom then emits a beta particle which has a velocity of 0.25 0.9 C. 0.9 C relative to the atom, relative to the atom in the direction of its motion, in the direction of its motion, in the direction of its motion. Full stop. What is the velocity of the beta particle? What is the velocity of the beta particle? What is the velocity of the beta particle? Come on. As observed by the experimenter. As observed by the experimenter. As observed by the experimenter. Do it fast. If you get the answer, okay. Otherwise, you take up the next problem. Because you are not opening your mouth. What I supposed to understand? Whether you have understood or not, how I supposed to come to a conclusion? Yes, Sabha. After 10 minutes, you are saying? Yes, sir. You have gone for lunch. No, sir. I also not yet finished my lunch. Sabha, unmute. Yes, very
sir.
good. Very good. Very good. Right. Now, shall I solve the problem or you people are going to solve the problems? Unmute, Sabha. Unmute.
So you solve it, sir.
I had to solve. Then, if I'm asking some questions, you people you have to answer it now. Why you people are not open your mouth? What happened? What happened? You people are capable of talking now. Yes, Sabha.
Yes, sir.
Yes. Now, shall I start to solve the problem? If you want me to solve the problem, just unmute and keep it as it is. Keep it as it is, Sabha. Okay, whether it is right or wrong, you go on answering. Because others, they are not answering anything. Almost I asked around about 10 students that I asked. But nobody has opened their mouth. Okay. Yes. Previous problem I had to solve or the new problem I had to solve?
Previous one, sir.
Previous one. From the previous one, I had to start. Then you read this question. Hopefully, you have read. Then I wrote 1 microsecond. Is that right? 1 mu, yes. Now use your basic knowledge. 1 microsecond, how to write in terms of seconds? 1 microsecond, how to write in terms of seconds? Micro means how much, Sabah?
10 power minus 6.
That's all. That's all I am asking. That's all I am asking. Why the other students are damn afraid? Oh, if it is wrong, then what? You people. Either it is right or wrong, they have to answer it. Okay, 1 microsecond, 10 to the power of minus 6 seconds. What is this? There are two concepts, T and T naught. T and T naught. What is this I supposed to write? Either T or T naught. Time interval, either T or T naught. T naught in the spaceship, T on the Earth surface. You tell me that now.
T.
T, correct? Again, you read the question. Proper lifetime. Proper lifetime means along with that movement. You know about the proper length. Similarly, proper time. So along with the spaceship, along with that laboratory, whatever the time interval is present, that must be taken as T naught. Okay. Moves through the laboratory. Moves through the laboratory. How much he has given? 2.7, 10 to the power 8 meter per second. What is this? Notation wise, I supposed to write. What I supposed to write? Throughout the problem, Sabha will answer.
Velocity V.
V is the velocity. Who is that? Who's spoken?
Rego.
Rego. Rego. Okay, right. So V is equal to 2.7, 10 to the power of 8 meter per second. Now T I supposed to calculate on the Earth's surface. That's all the common idea, that is C is equal to 3 into 10 to the power 8 meter per second. How long it has been traveled before it is going to get ending up, before it is going to get dies up, that particular the particle which is having a lifetime of this much, along with the laboratory it is moving. What is the time interval with respect to an observer on the Earth's surface we are supposed to calculate? So formula, T is equal to T naught. If T and T naught are exchanged now, then you will not get the answer. So be careful about these two. So T naught divided by square root of 1 minus V square divided by C square. Do the substitution. Get the answer here. Let me see that. Or shall I solve it? You see that. Shall I do the substitution and calculation also? Akash. Yogesh, he is showing the answer 2.29 something. Substitution, you do it. Do it carefully. The calculation. How much you are getting? You write it here. 2.946, 2.294. 10 to the power minus 6 second. Are you getting this answer? Yes, you check it out. Okay. Second question is also there now. Second problem, second question. What will be the distance traveled? So there is a particle is here. It is go on moving here. This is a particle. This particle is go on moving. At one particular time interval, it is going to get ending up its life. It stops. It is disintegrated. What is this distance? How much it has been traveled? The distance traveled is equal to how much? Right? The distance traveled is given by velocity multiplied by time. velocity multiplied by time. The velocity with which whatever it is traveling along with the laboratory is this. So therefore distance traveled is equal to 2.7 10 to the power 8, and this is a time interval 2.9 294 10 to the power minus 6. So substitution is over. The distance traveled you have to calculate using your calculator. So many meters. How much? Have got this answer, or shall I solve that also just to see that? If you didn't get the answer, I will show it how to solve that one. Only thing is you are supposed to ask. Some of you already shown the answer. Yes, what is this answer? $61.93. Yes, 619.4 something. Okay, whatever it may be. Right. So decimal point is here. 619. It is not 61. So carefully have to do the calculation. Okay. Yes. Next question you write. Already have given that problem. This problem number 7 is over. Today we have solved only one problem now. 8th one. An experimenter observes a radioactive atom moving with a velocity of 0.25 times c. The atom then emits a beta particle which has a velocity of 0.9 c relative to the atom in the direction of its motion. In the direction of its motion. Full stop. What is the velocity of the beta particle? You know about alpha particle, beta particle, gamma rays. Okay, one of the particle, that's all. Don't worry about that. Just it is a particle, beta particle. As observed by the experimenter. This is the problem. Read the question once, twice, thrice. You read it, understand. This question taken from which particular concept? Anybody? Name of the concept. Length contraction, time dilation, Einstein's time dilation, like that. Based on which concept? Relative velocity. Very good. Means velocity addition theorem. Velocity addition theorem. Using that, we are supposed to solve this problem. So first of all, we had to think about the problem related to what, which concept. Okay. By using the which concept, that we can get ready to solve that problem. That is most important for us to look into that matter. Yes. Let us take up that. An experimenter observes a radioactive atom moving with a velocity of 0.25 c. The atom emits a beta particle which has a velocity of 0.9 c related to the atom. Means there is an atom. The atom itself is moving like this, okay, with a velocity of 0.25 c, which emits a beta particle. This beta particle which is moving, the beta particle which is moving with a velocity, how much? 0.9 c. What is the velocity of the beta particle as observed by the experimenter? Okay. Then what is the velocity of the beta particle? We want to calculate. Here there is a person is standing. With respect to him, what is the velocity of the beta particle? This is how much? Yes. Hoping that you have understood the question. Now let me solve the problem. You know about the formula. Which is that formula? Velocity addition theorem formula. U is equal to U dash plus V divided by 1 plus V U dash divided by C square. Velocity addition theorem. This is velocity addition theorem. Only the thing is, which is V, which is U, U dash and other things that you are supposed to think. Okay. So in this case here, take your theory portion and you have to go through that. Without the theory knowledge, we cannot solve the problem. So what we have considered in the theory, like that we are supposed to take it here also. So in this case, V is equal to 0.25 times C. U dash is equal to 0.9 C. To an observer on the earth, how much it is looks like. Okay. Now you can do the substitution. These ideas are very easy, but selection of the formula. How to write these two, you have to think. Once you have written these two properly, then even an 8th standard student, if you are giving a scientific calculator, they will do that. Substitution calculation, they will do that. Okay. Yes, you do the substitution and calculation here. U is equal to U dash plus V 1 plus V U dash, Nicholas 0 point, okay, 0.9 C divided by C square. Okay, do it. Point 9387, correct? Times C. Somebody has shown it, cannot observe it. Okay, is it correct answer? Just to check it up. Still, further you have to write the answer now. We can write U is equal to 0.9387. C value, you can do the substitution for 3. For C value, 3.8 10 to the power 8 meter per second. So many meter per second. How much you are getting? Oh, everybody is showing different answers. 3.567. Is it correct, Nicholas? Ten to the power of 8, yes it is. Okay, plus 8. 10 to the power of plus 8. Okay, next question you write. 2 point something. How you got 2 point something here? Maybe calculator may not be showing properly. See that? Multiply these two. There you go. Yes, right now. He's showing 2 point something. 2 point something. 0.9387 into 3.8. What it is showing? Mr. Rego, Terianayagam, are you there at Martadli or at Mysore?
Smartly, sir.
Okay. So you see that? Why your calculator is not working? You are showing some other answer 3.567, 3.567. Okay. Yes. Next question. Problem number 9. An electron moves An electron moves with a velocity of 0.6 10 to the power 8 meter per second. Calculate its mass. Calculate its mass. Now, Rigo, yes, go on answering. Only one line question is there. You read it. Most probably you have already read so far. Just you tell me the data.
V is equal to 0.6 into 10 to the power 8 meter per second.
Very good. Okay. I have written. Then
Mass of the electron. Should write.
What is to be determined?
Mass of the electron.
Mass of the electron. Okay. What else is required? This is mass of the electron while it is in motion. While it is in moving, what is the mass? While it is at rest now, this is rest mass. Rest mass of electron. Rest mass of electron means when it is at rest. What is the mass of the electron? You know about what is the mass of the electron? Rest mass of electron. Electron, is it having the mass? Rigo. Electron, is it having the mass?
Yes.
No. No. Electron is having a mass. That rest mass of the electron is 9.1 10 to the power minus 31 kg. From high school level, we have started to give this concept. The mass of the electron, we are not going to say rest mass, just we are going to say mass of the electron. That is 9.1 10 to the power minus 31 kg. Here, the mass of the electron when it is at rest is this. When it is at under motion of this velocity, what is the velocity? What is the mass? Masses go on changing with respect to velocity. So, which is the constant formula I supposed to write? M is equal to m naught divided by square root of 1 minus Einstein's this mass relation, that is v square divided by c square. Okay, do the substitution and get the answer. These ideas we had to do the substitution here, do the calculation slowly, steadily, step by step. You write it. Don't do the calculation at a single step, because even at the time of examination we will see the steps also. Okay, without showing the steps, and if you are writing the answer, then we may not give you full marks. 4 marks, one question, one problem will be there. Got the answer? Krupa? $9.215. 9.2. Sabashi is showing 9.28. Jifli. Rego 9.28. 10 to the power. Sandhya 9.28, 10 to the power of minus 31. Yes. How many of you got the answer? Congrats. Yes. This is a concerned answer. Problem number 9 is finished. Got the answer? Yes. Take up the next problem. Tenth problem. Find the velocity at which the mass of a particle is double its rest mass. Yes. Sandhya, answer it. Only I will going to ask you about the data, nothing else. Only 1.5 line problem. Just you read once or twice, read it, understand. Just you tell me about the data, what I supposed to write here. Sandhya Rani.
Velocity, sir.
Find the
We have to
velocity.
find velocity.
We have to find the velocity. Okay, ma. Then find the velocity. Finish. Done. At which the mass of a particle is double its rest mass. Mass of a particle is double its rest mass. Which is the rest mass? M naught. Relative mass M. This is mass of the particle which is said to be under motion. This is the mass of the particle which is said to be at rest, 2 times of its rest mass. Clear? And we know that C constant, meter per second. Yes, take up the formula now. M is equal to M naught divided by square root of 1 minus V square divided by C square. Substitution, you do it. M is equal to how much? 2 times M naught. This is M naught as it is. Square root of 1 minus V square divided by C square. M naught on both the sides is going to get cancelled. Therefore, the remaining terms, whatever it is remaining, we are supposed to write it. Then do the cross multiplication. 2 into square root of 1 minus V square divided by C square is equal to 1. Therefore, squaring on both the sides, this is 4 into 1 minus V square divided by C square is equal to 1. 1 square is equal to 1 only. Therefore, 1 minus V square divided by C square is equal to 1 by 4. Hence, minus V square divided by C square is equal to 1 by 4 minus 1. Using this, I can write v square divided by c square is equal to 1 minus 1 by 4. Therefore, v square by c square is equal to 3 by 4. Correct? Therefore, v by c is equal to how much? Root 3 divided by 2. I supposed to calculate v. So using this, v is equal to root 3 divided by 2 times c. So therefore, v is equal to root 3 1.7 something now. You write that how much you are getting. This is 3 into 10 to the power 8. So therefore, v is equal to so many meter per second. Okay, got the answer? How much? 2.598 10 to the power of 8. Okay, Nicholas, right? Yashaswini, right? 2.598. Okay, Sandhya, right? Sharat, Jilfi, Joy, correct? Okay, next question. Maybe the last problem for today's question. 11th question. Question number 11. Calculate in electron volt. Calculate in.
Sir, we have quiz, sir.
You are having
Quiz exam.
quiz. Okay, I will stop it then. No problem. Which one? Chemistry or which
Chemistry, sir. Chemistry.
one? Okay. All the best. All the best. Okay.